In this video, I would like to discuss about electrolysis. As the name implies, electrolysis. Lysis means breaking. Electro means by using electricity or electric energy. So it means that we can break chemical bonds by using electric energy. Usually we also supply the chemicals with the electric energy, usually through a power source. So in an electrolysis cell, we have some important components. So the first one, we must have the battery itself, usually or other type of power source. And then the power source, of course, it's not safe if we dip it in the solution. So we will put an electrode or metals that can conduct electricity. The chemicals that we want to break the bonds, we will put it as solution. So something like this. So here we have some important components of electrolytic cell. First, we have the battery or power source. And then we have the electrodes, the metal rods that conduct electricity. And then we will have the electrolytes. So for the power source, we have the positive and negative terminal. And the electron will start to move from the negative terminal actually. So the negative terminal and the positive terminal. The negative terminal is the short one. So imagine that the electron will move here to this circuit, so that this part of electrode will be rich in electron. So this electrode, this metal rod, will be much more negative. Why? Because the electrons are moving here. Yeah, it fills the electrode. While this part, it will be the positive electrode. So then electrode we will have two. So the one which is negative we call cathode, and the one which is positive we call anode. If you kind of forget, then you can use panic. Positive is anode, positive anode, and negative is cathode. So you can determine the positivity or negativity of an electrode by doing this. Usually in electrolysis, you need to write the half reactions in cathode and anode. How can you determine what happens in anode and cathode? First, you need to determine the electrolytes, so the solution that we put here. So I would like to differentiate the electrolyte into two types. The first type is the molten type, and the second one is the aqueous type. Molten electrolytes, meaning that the electrolyte contains only the ion from that solution. For example, like molten sodium chloride. So only sodium chloride ions exist in this solution. While aqueous sodium chloride means that your sodium chloride is prepared by mixing sodium chloride with water. So water also exists here. The next important thing you need to do is that you have to dissociate your ions. So dissociate this. So differentiate between the metal ions and the non-metal ions. In this way, you can separate the positive ions and the negative ions. If you do know the charge, then you can refer to the ionic table. For example, like SO4 is 2 minus, and if you don't remember, you can always refer to the ionic table. For the aqueous also, you need to separate it. So for example, like this becomes sodium plus and Cl minus, and H2O actually becomes H plus and OH minus. Okay? So now, let's think logically. For every electrolyte, actually, there will be reactions happening in the cathode and anode. The cathode is the negative electrode because the electrons are running through it first. So this is the rich electron metal rod. Therefore, the cathode, since this is negative, it will attract the opposite ions, so it will attract sodium. So for molten, because there is only one positive ion, then this is the one that will go here. Because the metal rod is so rich in electron, so this metal rod can actually donate electron. It can give electron because this rod is so full of electron. Therefore, in cathode, the positive ion will receive electron to form a stable molecule. Why we only write Na? Because metals are monoatomic. So we don't write like Na2, no, we just write Na. What if it's another metal like magnesium, 2+? Then we plus 2 electron, because in order to form a stable metal, we need 2 electrons. So for cathode, it will always be the metal in molten, while for the anode, this is positive. So then we have to attract the negative ion. So in this case, Cl- will go here. So what happens here? Cl- actually has extra electron, because Cl- ion means that Cl- is Cl atom that already has extra electron. And because this rod is positive, this rod, it can still accept electron. So Cl ions will give electron to the anode, forming this reaction Cl2 and releasing 2 electrons to form Cl2. Why do we have Cl2? Because Cl is diatomic. Typically gases are diatomic. So F2, N2, H2, and so on. So if you see, then here, from the molten, sodium plus and Cl minus, then sodium will gather here and Cl minus will gather here. And it will receive electron, and it can continue the electron flow, so completing the circuit. Now what happens is if the reaction is in aqueous. So now it's getting a little bit more complicated because we have 2 options each. So for IGCSE, there are limited number of options, so you don't need to worry. For cathode, we have 2 options here, sodium plus and hydrogen plus. For cathode, actually, there is something that you need to remember. So either the special metals here, the special metal or other metals. If the other metals exist here, then it will be the one who will get into the cathode. But if it is other metals, like this one, so this one can sodium. So sodium will lose to hydrogen, and hydrogen will go to cathode instead. If hydrogen goes to cathode, what will it do? It will receive electron, so plus electron forming hydrogen. So we just need to balance this if it is other metal. What if it is this metal, for example like CuCl2? CuCl2 divided into Cu2 plus and Cl minus. So Cu2 plus will be reduced, forming Cu. So this is the difference. If it is the special metal or the reactive metal we say, then the metal will be reduced instead, because these metals really like to be reduced. But if it is other metal, then hydrogen will be reduced instead, because it is more difficult to reduce other metal compared to reducing hydrogen. Now let's compare the anode, the positive. So if the anode is halogen, halogen is group 17. So halogen typically is just F, Cl, Br, I. Then the halogen itself, it has 2 options. If it is concentrated and if it is diluted. If the halogen is concentrated, then the halogen will be oxidized instead here. So it will release the electron, forming the stable molecule. For example, like this one, forming Cl2 plus 2E. So this, or this one, Br2 plus 2E. If it is concentrated. How can we know that if it is concentrated or not? Sometimes it will be provided by the question. If it is diluted or it is non-halogen, for now, For example, like SO4 or NO3. Yeah, for now, we can refer that the OH will be oxidized instead. So here we have halogen. Halogen can beat OH. So Cl will be oxidized. But if it is SO4, for example, SO4 cannot beat OH, so SO4 will lose. So then OH will be the one here. It will release oxygen gas and water molecule by releasing 4 electrons. If you don't understand this, you can memorize this. But yeah, it's not really advisable. Okay? It will release oxygen gas. So in cathode, one of the main gas that will be produced is hydrogen gas, and in anode it will be oxygen gas if this is reduced, or other type of gas in anode. So these are the differences between molten and aqueous. What other things you need to know? We have an instrument also. It's called Hoffman Voltameter. It's one way to separate oxygen and hydrogen production from water electrolysis. So how to do that? First, we have to have an instrument that shapes like this. So the shape is like this. Okay, and then you put electrodes here. Then you connect it to a power source. This is water, H2O. In order to make the reaction goes quickly, we also put a few drops of H2SO4 or sulfuric acid. What do we need to do? We dissociate both. Yeah. So we separate them into the ion forms. Okay. So now let's check. The negative terminal is here. So the electron will move here. This one will be rich in electron. This will be the cathode. This one will be the anode. So what happened at cathode? Because it will attract positive ions, and the only ions that you have, the positive ions that you have, are hydrogen. So it's easy for us to determine that hydrogen will be reduced here. It will accept electron, forming hydrogen gas. We can just balance now. But now what happened at the anode? Since this is positive, so it will attract the negative ion, but there are two negative ions. So let's check, is it halogen? No halogen present, so it cannot beat hydroxide. Hydroxide will be oxidized here. So in a way, here, oxygen gas will be released in anode, so it will form oxygen gas. While here, hydrogen gas will be formed. If eventually the solution will be reduced in volume, it will decrease because the ions are going their own ways, becoming gas and escaping this instrument. We can just add additional water through this hole. So this way we can actually separate the oxygen and hydrogen production. The last thing that you need to know about electrolysis is electrolysis using copper electrodes or electroplating. So for electroplating, actually, previously we've discussed about electrolysis, but we never mentioned about the type of electrode that we use. If no information is given, this one usually is graphite. Carbon, which is inert or unreactive. Why would we like to use inert electrodes? So that these electrodes will not affect the result of the electrolysis. It's also stable and it can conduct electricity. Conductive, stable. Now imagine that we use different electrodes. Typically, one that is often appear in questions for IGCSE will be copper electrodes. So the solution, let's say that it is CuSO4. CuSO4, copper sulfate. So what will happen? One of the copper will be cathode, one of the electrode will be anode. So now it is actually a solution, so it exists also water. So now we need to separate both electrolytes, Cu2 plus, SO4 2 minus, and also water. In cathode, because this is negative, it will attract one of the positive ions. If we check from the list, actually copper managed to beat hydrogen, because copper is one of those easily reducible metals, very easy to reduce compared to hydrogen. That's why in cathode, copper will receive electron, forming copper metal. Now what happens in anode? So you can imagine, the copper actually going here, forming more copper, like it creates a layer in the cathode. Because it forms it forms more metal, it forms more copper. So you can imagine that as if this electrode, this part, it will be thicker, because new copper are latching onto this electrode. But what about the anode? The anode is positive. So typically it wants to attract one of these two. But this is the special thing. Because the metal here is the same like the metal here, so you can imagine as if that SO4 has a drive to restore the balance. It really wants to stay and maintain in its liquid form, in its aqueous form. Is there a way? Yes. It can actually grab the copper ions here, grab the copper, change it into copper ions to restore CuSO4. So restoring CuSO4 by grabbing the copper electrodes. In this case, in anode, copper will be turned into copper ions by releasing 2 electrons. So this will be the reaction that happens in cathode and anode. Typically for electroplating, there will be transfer of metal from anode to cathode. From anode to cathode. One of the requirements would be to have the solution as a bridge. To move and take the metal from anode and give it to the cathode. The solution will serve as a bridge. What if we just use normal graphite in this case? If we just use normal graphite, yeah, just to give you an image, an idea. So this is CuSO4, this is graphite and graphite, unreactive. So this one will be negative, this one will be positive. So in cathode, because this is negative, also water exists with this here. So CuSO4 becoming Cu2 plus SO4 2 minus, this one H plus and OH minus. Negative will attract one of the positive ions, so still Cu2 plus will win. What about in anode? Now, because the copper ion already going here, yeah, SO4 remains here. So now we have to judge whether SO4 is a halogen or not. It's not a halogen. Because it's not a halogen, it does not have a place in the anode. It will also lose. So OH minus will be oxidized. OH minus will turn into oxygen and water plus 4E. So this will be the overall reaction. See, comparing it to the one with copper electrodes, it's kind of different. So now you know that if we use different electrodes, then it would react differently with inert electrodes, such as carbon, graphite.